All right, number 3 is Morgan Stegemiller from the University of Idaho.
People have many different characteristics, different eye colors, different hair colors, different heights. These are all a result of the genetic diversity encoded for in our DNA. Similarly, sheep have many different characteristics, such as meat, fiber, and wool. There are many different breeds of sheep, such as the Targhee, which is a wool breed actually created right here in Idaho. There's also the St. Croix, which, as you can see from its long flowing mane, it's a hair sheep, and it's known for its parasite resistance. There's also breeds that are known for their fertility, such as the Romanoff. Using all of these different characteristics, many of them are encoded for by single nucleotide polymorphisms, or SNPs, and these are just a change in a single base pair at a location in the DNA. We compared 2 different programs to search through the 2.7 billion base pairs that are in the sheep genome in order to identify those SNPs associated with biological changes. Freebase, which is in purple, identified more SNPs than GATK haplotype caller in all of the breeds. We can then use this data to look at the differences and similarities between the breeds. The plot on the right clusters these breeds by genetic similarity. Each dot is a single sheep, and they are color-coded by breed. As you can see from this plot, there's a lot of genetic diversity between these breeds. We have the wool breeds, like the Targhee and the Rambouillet, up in the top left corner, and then all the way to the right of the plot is the St. Croix, that hair breed. Down in the bottom of the plot, the Romanoff pulls out. We can use all of this genetic diversity in order to understand the genetic causes for economically important traits, such as fiber, meat, wool, parasite resistance. Knowing all of this, we can also show the biological processes involved, not just in sheep, but that can be used as a model organism for cattle and even humans. We also know that over 65% of sheep in the world are located in developing countries, and this makes them vital in providing food for a growing population around the world. We can use the genetic knowledge that we have here in order to understand the biological processes behind many of these traits. From this, we hope to use this knowledge to identify and improve this genetic variation so that we can improve the U.S. industry in sheep, as well as provide food and knowledge of these issues for different things like infertility around the world.
That's great. So are you in the College of Ag?
I am in the
Life
College
Science?
of Ag,
Okay.
yep.
Your dean is here watching. Good job. I noticed he's here. So what is your major?
Animal science.
Okay, that's what I thought. Did you have sheep in 4-H and do stuff like that when you were growing up? Or?
I actually had alpacas in 4-H.
Oh, okay. I kind of guessed you might have been. But so
Yeah.
what got you interested in this research?
Yeah, so I've been interested in animal genetics for a long time, and I'm actually from Ohio, and coming out to the University of Idaho, my major professor was like, look, we have some sheep projects, and I was like, that's really interesting, getting to look at all this genetic variation and hopefully, improve the industry, which is, a great thing to do.
Great, great. Well, thank you and good luck.
Thank you.